Hello world, it's Calcutron here with the 5th episode of our series on programming in TI Basic. Today we will be talking about the Boolean logic operators as well as the comparison operators. With these tools, we can make much more powerful conditional statements using more complex logic. First, we are going to talk about the comparison operators, which take two numbers and return a Boolean depending on how the two numbers compare. Remember, in TI Basic, Booleans are represented by the numbers 0 and 1, where 0 is false and 1 is true. Let's take a look at using these operators on the home screen. So in order to get to the comparison operators, we do second and then math, which corresponds to the alpha letter A, and here we have a list of our comparison operators. Hopefully these look pretty familiar to you. We're going to start with the equal sign, which tests for equality. So with the equal sign, we give it our two operands, which are the things on either side of the equal sign, which is the operator. So remember that you have an operator and then you have the two operands on either side that you work with. Our first operand in this test will be 5 and our second one will be 6. So this is going to test if 5 is equal to 6 and return a Boolean depending on if they're equal or not. So we see we get 0, which is false. So 5 is not equal to 6. And if we try 5 is equal to 5, it gives us true. So this is nice, but when would we ever want to test if 5 was equal to 5 in our program? Pretty much never. That wouldn't ever be useful. What is useful, though, is testing if variables have a certain value. So we can do that ourselves, and let's just start with storing the value 5 into a, and now we can test if a is equal to 5, and we get true. So this is a much more useful way to do these tests. So there is something important to notice when you're using all of the comparison operators, which is where they come in precedence order, or what is their order of operation. So you might have remembered learning in school about something called Pemdas, or at least you very likely did if you were educated in America in the past several decades. But it's a very common teaching tool that teaches the order of operations. So first you evaluate expressions in parentheses, then you evaluate the exponents, and then you evaluate things that are being multiplied or divided. Then you evaluate things that are being added and subtracted. So one common point of confusion is multiplication does not actually come before division. So exponentiation does come before multiplication, and multiplication does come before addition, but multiplication and division have the same precedence, and same thing with addition and subtraction. So PEMDAS could just as easily be PED-MASA, but it's just not as catchy. So PEMDAS is a good way that you've probably been taught to remember the order of operations, but just a small catch is you don't always do addition before subtraction, and you don't always do multiplication before division. So for those things, you look left to right. But this isn't a math tutorial, this is a Boolean logic tutorial, so let's take a look at where does the equal sign fall into this order of operations. Well, it falls in after addition and subtraction, so it would be like this: PEMDAS equals does not equal. So equality testing happens after all of these other things. So this is a good thing. Otherwise, if we did this, a plus 2 is equal to 5, because equality has a precedence after addition, another way to write this, if we were being more explicit with our parentheses, is like this. So because this happens before, so because the addition happens before the equality test, we get our expected answer, which is 5 plus 2 does not equal 5, so 7 does not equal 5. But if we instead wanted to come in and put in parentheses, we could do that, and this would give us a very different answer. So it would be a plus 2 equals 5. So that would be a plus 0. So it's just going to be 5. So just an important thing to watch out for. In programming, we also have order of operations. So let's take a look at the rest of these equality operators. We've got not equals, so a does not equal 7, but a does not equal 5. And then the rest of these, hopefully you've had some experience with, but the greater than sign, if a is larger than 2, which it is, 5 is larger than 2, but a is not larger than 6. But what about, is a larger than 5? So remember, a is equal to 5. So is 5 greater than 5? Well, the answer is no. 5 is not greater than 5. But if we want that to be true, we can use the fourth operator, which is greater than or equal to. So you can see the symbol is kind of a fusion between the greater than sign and the equal to sign. So is a greater than or equal to 5 is how you would read this. And the answer is yes, a is greater than or equal to 5. And we also have equivalent less than sign. So a is less than 20. A is not less than 0. A is less than 20. So now we can test if a is less than or greater than a value. But what if we want to test if a is within a range of values? So the way we would do that is a is greater than, so let's say we're going for a is between 1 and 10 inclusive. So we want it to be true if a is equal to 1 and if a is equal to 10. So for that we use greater than or equal to. So if a is greater than or equal to 1, so that's one of our bounds, but we also want to check if a is less than or equal to 10. So what we want is to combine both of these tests so that when both of them are true, it is true. So when a is greater than or equal to 1 and a is less than or equal to 10, then we know a is within the range 1 to 10. So there's a nifty way we can do this, and that is with the Boolean logic operators. So if we go back into the same menu before, second math for our test menu, and we go over to the logic tab, we now see we have 4 logical operators. So we're going to start with AND. So we want to test if a is greater than 1 and a is less than or equal to 10. So if we evaluate this, currently a is 5, and 5 is greater than or equal to 1, and 5 is less than or equal to 10. So let's go in here and just evaluate this expression ourselves and see what occurs. So 5 is greater than or equal to 1, and if we put in 5 for a here, we get 5 is less than or equal to 10, so we can replace these with 1s because both of those are true. So if we evaluate this, we get the same thing. So true and true is true, but let's say we store 30 into a. And now we look at what happens when we run this expression. So remember, this expression tests is a between 1 and 10. And a is not between 1 and 10, so our expression works. It returns false. So let's take a look at what's happening. So let's replace these with 30s. And this is often useful when you're debugging something, to just look at the values, put them right in the expression, and evaluate it yourself, just like you are the calculator. So now we've replaced these, and we get, so 30 is greater than 1, that's true, so we can replace this with a 1. Now 30 is less than or equal to 10, that is false, so if we replace this with a 0, it should be the same thing. So true and false is false. And likewise, false and true is true, and or sorry, false and true is false, and then false and false is of course false. So the logical and works that if both of them are true, then what's going to happen is the output will be true. Otherwise, if either of them are false, or if both of them are false, then the output will be false. So I've been saying that 0 is false and 1 is true, but you might remember from earlier in previous episodes I've said 0 is false and anything non-zero is true. And that is a true statement. So if we do 5 and 1, we still get true. If we do -5 and 1, it's still true. If we do -5 and 0.02, and we put back our and we put back our negative sign, that's also true. But if either of these are 0, it becomes false. So the logic statements still output zeros and ones, so it's good to think 0 is false, 1 is true, but in reality, anything non-zero is true. So that's just something to keep in mind. So let's look at another example. Say instead of wanting to test if something's within a range, we want to test if something is outside of a range. So something's outside a range if it's less than the lower bound or it's greater than the upper bound. So let's write out this statement. So if a is less than 1, so if a is below 1, then we know it's not within our bound. And if a is greater than 10, then we also know it's not within our bounds. So the way we combine these, so let's say we use AND, because we know what AND is, and we know it can combine logic statements, or Booleans. So now we test A is greater than 10, and A is less than 1. Well, so A is 30 right now, so we wanted this to be true because it's outside of our range. So this one evaluates to true. 30 is true. 30 is greater than 10. That's true. But 30 is less than 1 is not true, so it's going to be true and false. And that's going to be false, but we want that to be true. So we're going to swap this out with a different logical statement called OR. So the next logic operator is OR, and that will be true if either one of our parameters are true. So if either one is true, or if both of them are true, then OR will be true. And it works a lot like, these logic statements are exactly like what you would hear in language most of the time. So you'd say, well, we know that A is outside our bounds if it's greater than 10 or it's less than 1. You wouldn't say if A is greater than 10 and it's less than 1. You wouldn't say that. So a lot of the times you can think, what do I want to test, and think of it in English and then translate it to your logic operators directly without having to do any conversion. So it works a lot like regular language. So if we change this to an OR, we can see when A is 30, it's true. If we change A to 5, it's false, because if we look at this, 5 is less than 1, 5 is greater than 10, so 5 is not greater than 10, so that's a 0. 5 is not less than 1, so that's a 0. So 0 or 0 is false, but 0 or 1 is true, 1 or 0 is true, and 0 or 1 or 1 is true. It's really important that you thoroughly understand the AND and the OR, but you saw in this list of logic operators one more that you might not have heard of before, and that's XOR, which is for exclusive OR. So I'm going to explain what exclusive OR does, but this is not something that will probably ever or at least very rarely, crop up in our TI basic programs. You can always use ands and ors to simulate an XOR, and very often you don't need XOR. So when we're writing TI basic programs, it's often not necessary, but if you're doing digital logic and you're an electrical engineer, or if you're writing low-level assembly code, if you're working really close to the ones and zeros in the hardware, XOR can be useful, but generally in higher-level programming languages like TI basic, it's not very useful. So I'll explain what it does, but you don't need to really... It's not as important that you remember what XOR does as it is that you remember what AND and OR do. So let's see. XOR on two false things gives us false. So what XOR stands for is exclusive OR. So we'll see what that means in a second. So 0 XOR 1 is true. True XOR false is true. And here's where it differs from OR. 1 XOR 1 is false. So true XOR true is false. So that's why it's called exclusive OR. So if exclusively only one of the operands are true, then it will be true. So if they're the same, if they're both true or they're both false, it will be false. And if they're different, then it will be true. So like I said, you don't need to remember this one quite as much as you need to remember what AND and OR do. So the final logical operator is not. And I bet you can guess what this does. We won't use it in any examples just yet, but it's useful and you should keep it in the back of your mind when you're writing statements. So not false is true, and then not true is false, just like that. So it's these logic operators, they shouldn't take too much thinking in order to decode what are they going to do, because they work just like English does, or at least very similar. Sometimes when people are speaking English, they use OR and XOR interchangeably, but now you know the difference, and in general you can just think, what do I want to say in English, and then translate it directly to the calculator. So if you need a little more help understanding this, and maybe you want a refresher on what we've learned so far, I'm going to be putting up a program that computes the quadratic formula, or uses the quadratic formula to compute the real solutions to a degree 2 polynomial. So I'll be putting up another video that's not part of this tutorial series that will get into that specific application of the things we've been learning over these 5 episodes. So if you need a little more practice with the things we've learned so far, do check that out. And I've also put up a standalone tutorial for the temperature program that we coded over the past couple of episodes. So if you want to go over and review the material we've learned so far, that's a good way to do it. And as we learn more things, I'll probably be doing that more often, where we take what we know and we make a program with it, and that's a standalone video that's not part of this series. So once again, that's only if you need extra practice, so we won't learn anything new in those videos, but they're good for reaffirming what you've learned here. And once again, this series is for complete beginners. So some people with more programming knowledge, go ahead and fast forward through some of these earlier videos. I know sometimes I go a little slowly, but that's because I think everyone should learn how to program on a calculator. I think it's an essential skill, and these calculators are a great place to learn. And so I'm going to go slow so that beginners can get a hold of it. And I hope that you enjoyed this video, and if you have any questions, please leave them below or comments. And have a nice day. Bye-bye.